Hello and welcome to an introduction to geometric series. So this right here is the Greek letter sigma, and that is a capital sigma. It's a Greek letter, and most of the time in math that's going to stand for us that we are going to be doing a sum. We're going to be adding things together. So now the a of I is some sequence that we have. So A of I is some sequence. It could be an arithmetic sequence or a geometric sequence, or it could be just a sequence of random numbers. So it's whatever the sequence A of I happens to be. The number in the bottom tells you what term we are going to start at. So we are going to start our sum, in this case, using the first number in the list. So we're going to start at term 1. And then the number at the top tells us where we're going to end up. We're going to end at term 7. So basically all of this notation here, if I put this all together, what this is saying mathematically is that we're going to take this sequence of numbers, this A of I, this particular sequence, and we're going to start with the first number in the list and go up to the 7th number in the list, and we're going to add all those numbers together. So we're going to add the first number, the second number, the third number, the fourth number, the fifth number, the sixth number, and the 7th number. We're going to look at what that sum is. So I picked a particular sequence here for A of I. Here we go. And let's work out what this sum would be. So we are evaluating the sum from the first term to the 7th term of A of I. I'm just going to write the explicit form right here. That's what A of I is. So the first term would be 625, followed by, I'm going to add, the next term is negative 125, and the third term is 25. The fourth term is negative 5. The fifth term is 1. The sixth term is negative 1/5. And the 7th term is 1/25. So how am I getting these terms? Well, I'm taking the I value of 1 to start off, and then substituting 1 into I here. And then working that out, that gives me 625. Then I'm going to make I2, substitute 2 in for I there, work that out to get the second term, and then so on and so on. Or I could think of the pattern here. This geometric sequence starts at 625, and then to get the next number in the list, I just multiply by negative 1/5. So that gives me negative 125. Then to get the next number in the list, I'd multiply by negative 1/5 again to get 25, and so on and so on. And if I add all of these together, let me just do that really quick on my calculator, I get 520.168. So that is this sum. If I add the first 7 numbers in this particular sequence, I'm going to get 520.168. Now, this is sort of tedious to add all these numbers together, and our sequence is geometric here. So, well, our sequence A of I is geometric, so that makes this a geometric series, and there's sort of a shortcut for working out sums of geometric series, and here it is. I should probably throw some parentheses around that denominator as well. So this formula will calculate a finite geometric series for us, so this sort of takes out a little bit of the tediousness. For example, if our series had 50 terms in it, I wouldn't want to add up all those 50 terms. That would take a long time even to just type in the calculator. So let's work this out with our particular example. So the first 7 terms of this geometric series. So let's work this out. This is the first term here. A1 is 625 times 1 minus the common ratio, which is negative 1/5, raised to the n power. So the n power in this case is like how many terms do I want? So I'm going from the first term to the 7th term. So raise that to the 7th. Then I'm going to divide all of that by the quantity 1 minus the ratio, so it's 1 minus negative 1/5. So there's a lot of parentheses to keep track of here, and you should try to evaluate this out on the calculator yourself to make sure you're getting the correct answer of 520.168, and make sure that answer matches up with when you actually add up all of the 7 terms in the sequence to evaluate the series. Make sure those check out, and good luck when you're doing your problem on finite, on series in general, and on finite geometric series. Just a quick correction. I've actually gone back and checked my work, and I found out that I calculated this sum wrong. I didn't take my own advice. I was careless when I entered this into my calculator. This sum should be 520.84. So if you got 520.84, you were doing this correctly, and I was not. Same thing over here. It's not 520.168, it's 520.84. So sorry for that mistake. Hopefully you were getting the correct answer, and good luck.